welcome to another episode of 3D Prototyping in Unity. My name is Kasanas, and the last episode we took care of the asset design and the animation states to be able to jump. In today's episode, I'd like to take a look at the code and actually get our character jumping. Alright, let's get started. Okay, so there's not a lot to do within the actual coding side of this. We might have been able to squeeze it into one video, but I really hate going on beyond the 15 or 20 minutes. So let's take a look at this. The idea behind this jump is a gravity-based jump, meaning we're going to apply a force to a rigid body, cause that rigid body to move into the air, and we're going to then use the rigid body's velocity in the y direction to determine what state of animation it should be in. We made sure that we set up our ground object right here, our ground cube, to be on the ground layer. Anytime our character is connected to a ground layer, our character is considered to be on the ground. As soon as we are no longer on a ground layer, then we are no longer grounded, and we are either jumping or we are falling. We're going to determine whether or not we're on a ground layer based on a small sphere that we're going to design underneath this character's feet. The sphere is going to be placed at this ground check location. We're going to draw the sphere there. We're going to check and see if there's anything there that's ground, and if there is, our character is standing on the ground. And if there's not anything from that layer there, then our character is either falling or jumping. Okay, that's the plan. Last episode we went through and we made sure that our animations were set up. Our animation state is in good shape. We are going to move from any state, so we can move from any of our states into this jump blend. And the jump blend is either going to it has two different blends in it. It has a fall and a jump. We're going to move through either one of those. After going through that, once we've left the ground, we're going to go to there. Once we touch the ground again, we're going to move into our player landing state. From there, after a specific amount of time, we're going to move into our substate, our idle substate. Okay, that's the plan. So let's take a look at the code right now. If we go to our custom player and we scroll down and we open up our player controller, double click, and let's have a graphical error. Boom! Let's try it again. There we go. So we're opening up our player controller. And what I want to do, let's add a couple of, this is for jumping. We're going to add a couple of variables in here to help us control our player. What we're going to need is we're going to need a bool. Excuse me. I think I'm catching a cold. We're going to need a bool that we're going to call grounded. We're going to call it grounded. And grounded is going to be true if our player is touching the ground, and it's going to be false otherwise. All right. We'd like a reference to our rigid body. Oh, I spelled that wrong. Rigid body. That we'll call myRB. Okay, and we will define that a little bit later on. We're going to need a number of things to define our collision with the ground. So let's start off with an array of colliders. And we'll call these ground collision. We'll call them ground collision. Let's call it ground collision. It doesn't really matter what I call it. Ground collision. That's going to be an array. Now, in our case, it's an array, but it's probably not necessary. We're only going to collide with one bit of ground, and that is our actual ground cube. There's nothing else in our scene that is considered on the ground layer. All right. So maybe maybe that's a little too, the array is kind of an overkill there, but you could easily take this code and use it on something else where you had a number of different things you may touch at the same time. Really, all that matters is you're touching any one. So maybe we don't even need an array. It doesn't really matter. We'll leave it as an array though. I would like to set up, so the way that we fill this array is by creating a small sphere under our character's feet. I want to create that sphere at a specific location. Let's have in here a serialized field. And that serialized field is going to be a transform. And that transform is going to be the location, the transform's position is the location where we're going to actually draw our sphere. And in our case, it is linked to, let's go back over here and take a look. It's going to be linked to this ground check that we built last week. Okay? So let's call this, I don't know, let's call it ground check. Oh my god, my spelling's terrible. Position. Alright, ground check position is probably fine. The next thing I want to create is, we're going to want to actually create the sphere. This is where we're creating it. And let's decide how big we're going to create it. So let's have a float that we're going to call check radius. And let's set equal to a value of, let's say, 0.05. I'm not sure if that's the right value, 0.05f, but we'll see. If it's not working out properly, then obviously we're going to have to make a quick change to it. We're going to need, what else do we need? We need to have a layer mask that we're checking this against, because we only want this collider array to be filled with objects that have the ground layer. So let's make a layer mask. It's gonna be a public. No, sorry, not a public. Let's make it a serialized view. Serialized field. Excuse me. Keep saying serialized view. Serialized field. It's gonna be a layer mask. That we'll call, I don't know, ground mask. Oops. Ground mask. There we go. And one last thing that we're going to need is a serialized field that it's going to be a float, and this is going to be our jump power. This is going to be the amount of power that we apply to our rigid body to have the rigid body shoot off into the air. Okay, and I think that's all we need. We will see as we move forward. Let's go down into our start menu. Sorry, our start menu. My God, I'm saying all the wrong things. Our start function, and what I want to do is I want to define our rigid body. Let's make a reference to a rigid body. So my RB is going to be equal to get component, and we are looking for a rigid body. I'm only using get component because this actual script is on the same location, within the hierarchy as the rigid body itself, so we can use our get component, round brackets, semicolon. That's our proper that's the proper format right there. And I think last week I forgot, or 2 weeks ago I forgot to put set is running equal to false to start off with. We don't want our character starting off running. So is running is equal to false, and that's all I think I need. Yeah, that's probably fine. Now, there are a number of things we want to do also. We want to go down. Let's head down in here into our update. And the way our update is going to work is we're going to check to see whether or not our character is grounded and whether or not the player is actually pressing the button to make sure we jump. So let's start off with an if statement. And if we are grounded, and our player is pressing the appropriate button, we're going to use the input dot get axes. And we'll take a look which axis that is in a second. If this axis is greater than 0, the value is greater than 0, then we actually want to be able to jump. All right? Let's go over and take a look at which axes we're going to be using. To see our axes, we're going to go over here to Edit. We're going to find our project settings, input, and bam, it's going to appear right over here. And you can see I've already got jump selected right here. It's a number down, jump, and it's linked to the positive spacebar. There's also a jump right here linked to the, what else is it linked to? To joystick button 3, all right? So you've got access to either the joystick or the actual keyboard here. So whenever our player presses the space bar, our character should jump in the air. So let's add that in right here. Get axes, quotations, jump, quotations. Perfect. So when that occurs, we actually want to do a number of different things here. The first thing we want to do is make sure that we set the animation state the parameter of our animation state is grounded to false. So player anim dot set bool, and it was called is grounded. I'm sure it's called is grounded. I just want to double check because if I get it wrong, it'll suck. Is grounded, yeah, is grounded. So we're going to set the value of is grounded to false, so comma false. All right, and that'll immediately send us along the path to the jump. That's going to send us, as soon as we set that, it's going to send us from any state we're in into our blend tree, and we're either going to be falling or we're going to be jumping based on the vertical speed. Now, the next thing we want to do is we want to make sure that we've added a force to our player, to the actual character, and we want to set it to the character's rigid body. So we're going to say myRB dot add force. All right, add force is a built-in function, and we want to add force only in the y direction to create a y velocity. We don't want any force added in the x or the z. That'll cause our character to fall off of the edge of the platform, and we don't want that at all. So we could either just take the unit vector, the vector 3 dot up, and multiply that by our jump force, or we can just set a brand new vector, which I'll do right here. We'll set a brand new vector 3. That we will have 0 force applied in the x, we will have jump power applied in the y, and 0 in the z. All right, and lastly, what we want to do is we want to add a force mode. We want this, let's just type force mode here. We want this to be an impulse force, meaning that the entire force is added at once, and afterwards there's no additional force applied. The character will have this force applied, shot up in the air, and then gravity will take over and allow our character to fall back down. Okay, and lastly, we want to immediately set our grounded state, our grounded state here, equal to false. So now we have our is grounded set properly in our animator, and we have the grounded state within this script set as properly as well. Okay, perfect. Now there's a couple more things that we want to do, and we want to do it every update. So we're going to do it right here within the update as well. We want to check to see if we're actually connected to the ground. Okay, so what we want to do is we want to fill our ground collision colliders with a collider if it's actually in some way connected together. Okay, so we're going to use a built-in physics function, physics.overlapping circle, or overlap sphere, excuse me. And the overlap sphere allows us to create a very tiny sphere in some location. And that sphere will have associated with it a collider, and that collider can be used to check against a mass to see if we're actually in physical contact with something else. So we're going to use the overlap sphere. We are going to place this sphere at our ground check position, dot position. So ground check position was a transform. We're going to look at the transform's position, and we're actually going to draw our little sphere in that location. We actually want to draw our sphere with the, what did I call it? What did I call it? Ground check radius? What did I call it? Ground, did I even have that? Did I even add that? Let me see. Just called it check radius. Just called it check radius. So we want to make it with size check radius. All right, and lastly, we want to check our colliders against a layer mask. In this case here, I've already forgotten. Getting old sucks. Ground mask. All right, ground mask. So we want to check it against ground mask. All right. So this will return any results, with the items in the layer ground. Otherwise, it's going to be ignored. Okay, so this is going to automatically fill our ground collision array. Now, the only thing we actually care about is if our ground collision array actually has anything in it at all. We don't care what it is, as long as there is something with the layer ground associated with it inside of this array, then we're all set. So if ground collision dot length is greater than 0. If it's greater than 0, that means we're actually on the ground, and therefore grounded equals true. Bang. And the last thing we want to do is, if we're not actually grounded, else, then grounded equals false. Okay? So we've now got a value for our ground, and we know whether or not we're touching the ground. If we're not touching the ground, we're falling or we are jumping. The last thing we want to do to make sure our character is working properly is give this information to our animator. Okay, so player anim dot, we want to set a bool here. We want to set our is grounded state. We've already done it up here, but we're going to keep setting it every frame. So set our bool, which bool is grounded, and we want to set is grounded to the condition of grounded. Okay, bang. All right, there we go. And lastly, we want to say player anim dot, we want to set a float, and we want to set the vertical speed. Okay, quotations, vertical speed, quotations, and we want to set that the value of our rigid body, my RB, dot velocity of the y only. We only want to set to the value of the y. That'll tell us if we are falling or we are rising upwards. Okay, I'm going to file save this. File save. Perfect. Let's head on over here and make sure everything's worked out properly. We'll click on our custom player, and if everything's worked out properly, then we are going to have a number of, a number of serialized fields that are available to us. First of all, we're going to have this ground check position. Right now it's set to none. We actually want to set our ground check position to our, let's look at the scene, to our ground check, which is right here at the very base of our character's feet. let's go down here. Let's scroll back down now and drag our ground check into the ground check position. So we're building the sphere at the right location. The next thing we want to do is set our ground mask. Our ground mask is going to be set to our ground layer. Perfect. And lastly, we need some kind of jump power. And I don't know what that is. I'm going to put 1. That may or may not work. I don't know. All right, let's file save our scene. File save our scene. And lastly, let's hit play and see if we've got this thing working. Play. Let's see what we get going on here. All right, so the character bowed down. He obviously wasn't touching the ground to begin with. He was immediately assumed that the character was actually off of the ground and therefore went through the falling animation and the landing animation. And that's fine. It looked horrible. And I apologize for that. Like I said, guys, this character was not set up with a landing animation. So before I hit jump here, just keep that in mind. It's not going to look good. I'm not expecting it to look good at all. All right, let's hit play. Play. Our character jumps and does his land. The land looks awful, but that's the way it goes, I guess. If I had set up the character properly, then we would be all set. All right, so we can see we've got one little problem here. The camera does not follow the character, and we really want it to. We really want it to follow the character. So that's the last thing we're going to do here. The jump itself is working fine. Everything seems to be working fine. And there's one other thing we want to correct, but we'll probably correct it in the next episode. What I want to do right now, we're starting to run out of time here, so what I'd like to do is I'd like to make one last adjustment to our actual camera. And let's go to our camera control group right here, and currently our camera is set up so that we can rotate our camera around this position and actually see our character. We've got it set up right here. I'm going to add one more script, add script, a brand new script, and I'm going to call this the camera follows script. All right, and the camera follows. Let's open that up. And what we want to do with the camera follow script, I hate this error. With the camera follow script, what we want to do is we want to make sure that the camera is following the character up and down. Okay, so let's go in here and I'm going to add a serialized field, and this is going to be the transform. It's going to be the target that we're following. Okay, right now we're going to be following the actual character, so we're going to add the character's transform in here, and we'll simply call it target. Okay, and I want to add one more thing here. I want to add a serialized field, and it's going to be a smoothing effect that's going to occur on the camera, so our camera movements aren't very jerky. So we'll add a float that we'll call this smoothing. And we'll set it equal to 5F for now, and that should be fine. The last thing is I set up a vector 3, and it's going to be an offset of the camera. Basically, wherever the camera is when the game starts or this project starts is the offset I want to maintain. So we're always going to be trying to maintain that offset between the player and the actual camera itself. Okay. In the start function of this particular script, we are going to add a offset. We're going to set our offset value to something. It's going to be equal to our transform dot position, so the transform position of our camera, minus the target's transform position. The target transform position. All right, there we go. And what we want to do is either during the update or the fixed update, you can pick which one you want. It doesn't really matter. This is not physics-based. Well, the jump is physics-based. Usually anything that's physics-based, you want to make sure you're doing in the fixed update. I'm going to put this in the update, and we'll see. If I don't like it, I'll move to the fixed update afterwards. All right, basically what I'm going to do is declare a vector 3. And I want this to set our target cam position. So our target, it's going to be called target cam position. Let's just call it camera pose, is equal to our target's position, our target dot position, plus the offset that we've already calculated above. All right, and now we want to smoothly move towards that position using our transform dot position. So we're actually moving the position of our camera position. It's going to be equal to a vector 3 lerp, vector 3 dot lerp, and the lerp allows us to move smoothly between two numbers. So we're going to be moving from our transform dot position to our target cam pose, target cam pose. That's our new position. We're going to apply to it a smoothing value, and we're going to multiply our smoothing value times time.delta time to make sure that the smoothing occurs in a nice slow and smooth pattern. All right, let me save this. File save. And we've got a couple of serialized fields in here. We only need to fill in one of them. One should be automatically filled. Let's take a look at our camera control. There it is right there, automatically set to 5, which is great. And our target transform we're following is the actual player. So let's drop that in there. When I hit play now, our camera will follow along with our player, keeping the player on the screen. All right, my God. Every time I see that Band-Aid animation, it makes me sad. Anyway, guys, that's all I wanted to do. I hope you enjoyed it. Our jump is working fine. It looks terrible, but our jump is working fine. Guys, take your time and make sure you're planning ahead. If you're using this to demonstrate your animation skills, make sure that you go through and you build the appropriate animations. I needed a fall, I needed a jump, and I needed a player land. I didn't have one. There's not one associated with this character that I've given you. So if you're using your own stuff, yours will look much better. Alright guys, thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.